I welcome you back from the lunch time that you have been having. I also like to thank you for completing the exercise that I gave you when you were moving before you went for your lunch. At this moment, I would like us to look at something different. When we met last time, we were looking at simple machines, the group of simple machines. And under that group of simple machine, we had picked mainly levers. And that is what we have been looking at. At this time, we are going to look at another group of levers, another group of simple machines. We have finished to look at levers. At this time, we are going to pick another group of simple machines, the second group, and we are talking about inclined planes. An inclined plane can also be called a slope. So another name for inclined planes, which is a group of simple machines, is also a slope. When you meet the word, maybe when an examiner is saying, define the term a slope, it is the same as define the term an inclined plane. Now, when talk about an inclined plane is a slanting surface that joins a lower level to a higher level. I repeat this. An inclined plane is a slanting surface that joins a lower level to a higher level. An inclined plane is a slanting surface that joins a lower level to a higher level. I'm going to do a demonstration of what we are calling an inclined plane or a slope using this ruler that I'm holding. We have this ruler and we have a simple table here. Then we have the ground. So on that point, we have to make our inclined plane is going to be very simple. This one is a higher level. The floor is the lower level. So if we want to join these two levels, we are going to use this ruler and we shall put this ruler on the floor down there, and also we join it to the higher level. So this ruler makes what we call an inclined plane or a slope. This ruler, the distance, this one here is what we are calling the inclined plane. A slanting surface that joins a lower level to a higher level. So this is what we are calling an inclined plane or a slope. Now, when we talk about the inclined plane, a slope is mainly used to load. It is used to load some objects from the lower level, maybe to tracks that are raised to a certain level, using less force. From here, instead of you raising, for example, if you want to carry, if I have, this is the load, which is down. If the load is down here, instead of me carrying this heavy load from down here straight to a higher level, it will be very simple for me to use an inclined plane whereby I'll put my load here. Then after putting this load, I'm going to, not to raise it using my energy, but I'm going to use this inclined plane, the slope. I'll push it via this slope here. I'll push it here. I'll use less energy to push it here until it reaches the higher level where I need it to go. So, using an inclined plane to load some heavy objects, to raise heavy objects on a higher surface, requires less energy than for you to raise them from the ground directly up to the higher surface. Now, that is what we have called the inclined plane. I repeat the definition. An inclined plane is a slanting surface that joins lower level to a higher level. I have already explained this by saying a less force is applied in getting on an object to a higher level than lifting an object directly from the lower level. If you are using an inclined plane, then the less force is applied. Now, how can one reduce the effort needed to move an object on a slope? If I want to use less energy, this is my inclined plane. but we are seeing still there is some steep slope here that will need some kind of energy still. If I want to use less energy using this inclined plane, what do I do? I'm going to make sure that if this ruler was a little bit longer, then my inclined plane, I would make my inclined plane longer if this ruler was long. So we would have a surface that is slanting in some gradual way like this, and it is standing somewhere there. This one here would make lifting an object from the other side, bringing it on the higher surface here, would be very easy. And I would use very little energy because my inclined plane or a slope is longer. It becomes longer. So we can reduce the effort of lifting objects on an inclined plane by making it longer. You make this surface, the slanting surface, longer. We are looking at one of the main points here. We are saying the longer the slope, the less force is needed to move an object up the higher level. When the surface of the slope is long, you use very little energy to push a heavy object on a higher surface. When the surface of an inclined plane is long. This one is a structure showing an inclined plane. This one here is a slope that we are calling an inclined plane. Then we have this height, BC. Then we have this slope, AC. AC is an inclined plane. And this slope here, I have said here, the way I have named it here, this is not the naming, I have described it. Here is just a description. AC is the distance where you need to push where the force will move, where you will push your objects, AC. So when I need to push my object to a higher level here, I'm going to put it here, then I push it via this slanting surface until it reaches where I need to park it here. So AC is the distance moved by effort, the effort distance, AC. Then we have BC. If this is the level of the ground, instead of me picking an object and raising it directly, now I'm using an inclined plane. BC becomes the distance moved by the load. BC is the distance moved by the load. I repeat this. AC is the effort distance. BC is the distance moved by the load, the distance at which you have to raise the load. Now, I'm trying to explain this. I'm explaining this because this is what we use when we are calculating the mechanical advantage on an inclined plane. When we are calculating the mechanical advantage on an inclined plane, we say mechanical advantage is equals to the effort distance divided by the load distance. Effort distance divided by load distance. We divide the effort distance to the load distance when you are calculating the mechanical advantage on an inclined plane. Now, this angle A is the angle of inclination. A is the angle of inclination. Looking at examples of inclined planes, examples of slopes, we have the first one is what we call a plank of wood. A plank of wood or a ramp. A plank of wood or a ramp is an example of an inclined plane. Here is the picture. This is the level of the ground. This is the soil, and someone is raising an object from the soil, pushing it to a cart. Not the other cart that eats rats, okay? This cart, the cart that is used for carrying goods using the horse. So you can load your sacks on a cart using an inclined plane, which is a plank of wood, a slope. You put some timber here, then you'll be pushing the logs or the sacks into the cart over that timber. So this is a plank of wood, which is also called a ramp. It is an example of an inclined plane. Then we have another example. The second one is what we call a winding road. A winding road is simply used on mountainous areas. For some of you who have ever traveled to mountainous areas in Uganda, for example, when you go to Kapchorwa, it's a mountainous areas and they have some kind of town up on the hill. So a winding road is normally used on those hills. You cannot move on a hill directly like this, but you'll find a road that meanders around a hill. You move in a circular way until you reach on the top of the hill. So that is what we call a winding road. It is an example of an inclined plane. Then the third example we have the staircase, which is, locally we call them steps, the ones that we use when we are climbing on the floors of a flat or flats. We normally use them in our schools, those staircases. When we are coming from down and you are moving upward to the class, you use the staircase to climb up. It is an example of an inclined plane. Then the last example, the fourth one, we have what we call a ladder. All of us have ever used a ladder. When you want to climb on a roof or you want to climb on a tree, you can put a ladder and you use the ladder to climb up. Instead of climbing directly from the wall, you can put the ladder, then you use that. So a ladder is an example of an inclined plane. We would like to look at how do we find the mechanical advantage of an inclined plane. That is the next step that we are going at. Mechanical advantage that is represented by MA of an inclined plane is equals to the effort distance divided by the load distance. Effort distance divided by the load distance. When I was explaining the other one, I told you that the distance here, this slope here, is what we call the effort distance, while this height is the load distance. So we shall have the effort distance, which is 100 kilogram force, divided by the load distance, which is 25 meters, which will give us 4. Remember at the first point when we were calculating the mechanical advantage, we said the mechanical advantage has no units. It has no units. So this inclined plane uses work 4 times. This is the mechanical advantage of this inclined plane. And this is how we work it out. When we're looking at the other mechanical advantage, when we're calculating them, we said mechanical advantage equals to effort divided by load. Here we are saying mechanical advantage is equals to effort distance divided by the load distance. I'll come back with the exercise for this. However, I request you to revise them, go through it, and understand them properly. Thank you very much.